So last week we already learned how to create the point.py. So let's see the point.py here. We have data members. So this data member means the variable. And then we have the method or function. This is a method or a function to translate. It means I have two parameters, dx and dy. So I can change the value x. So the x will be added with the dx and the y will be added with dy. So we can test the code. So we know that this is the statement to import the point. So I'm going to import from the point.py, which is this one. And in this point.py, we have a class point. So I'm going to use the class point, and this is the main function. So I will call the main function here. Okay, you can see I have the main function. So the main function, first I will create an object p1. And we know that the point class has two data members. We have x and y, and it starts from 0. So I change the x into 2. Now we get the p1x and p1y. I have another point which is p2, and I would like to change the py, the y of p2 equals to 4. And then I have a formula multiplication. So I can multiply 4 with 3, and then for x, I will do the addition. So the result will be 4 multiplied by 3, then y will be 12. X, it is plus 1, then p2.x will be 1. In this problem, we have a method or function translate. So in the function translate, we know that there are two parameters, dx and dy. So the current x will be added with the dx, and the current y will be added with dy. Then what is the current x here? This x is 1 because x is originally 0 and will be added by 1. So 1 will be added with 10. And then y, which is 4 multiplied by 3, which is 12, and it will be added with 20. So it becomes 32. So if you run this, so after you translate the P2, it becomes 11 and 30. But for the P1, it remains the same, 2 and 0, because we do not do any translation. In this method, in this function, we have self. Okay. So the self is a parameter that reference the object itself. So using the self, you can access objects member in the class definition. So when you use the self, it means if it is P1, then it will check the data for P1. If it is P2, then it will check the data for P2 itself. Then it means you don't need to figure out every object for the data. because Python has this self to indicate its own object. Okay, so let's move on to the next. We call this is the instance method. The instance method, the translate is the instance method. It means this exists inside each object of a class and defines the behavior of that object. So we call this is the function or the instance method because we can access it based on the instance. So what is instance? So in this case, what is the instance? If nobody raise your hand, I will call your name, but I will not give you any point. We call P1 is the instance. We call P2 is the instance. As you may know, this is one instance. So we have one data. This is another instance. This is another instance. So if we have three data, it means we have three instances. Now we have here we have two instances. We have P1 and P2. So if you call P2, when you call P2, and then when you write dot, you can see that we can call Y. Y, F. What is F here? Can you see? Yeah. And then we have M. What is it? F is the data type. Okay. So Python is automatically give the data type. If you remember, we have the data type integer, float, string. So those are the three basic data type in Python. So if there is no definition, usually Python will give you directly F or float. So we have this M, or this is a kind of method. It has the dx. So you can see self dx dy. So this is a method, or it is a function. And this function will be called based on the instance. So you need to make the P2 dot something to call the translate. So we call this is the instance method, because when we call this method, there should be an instance. If we have P1 dot, so P1 is also another instance, then we can also call the translate. And we know that there are two parameters, dx and dy. So we need to give two values. Okay, so that's the instance method. When we have the instance method, we need to have one parameter which is self. And to call the data members, it requires to use self, since it is to access the object's data members. So this is necessary because whenever you call the data members, what is the data members? Here is X and Y. Okay. Based on the definition, the data members, we have X and Y. In order to call these data members, we need to use self. That's why we need to define self in the instance method. Okay, so this is different with the common method or the common function that you already learned previously. For example, in the chapter, maybe in this chapter, okay, in this chapter, you can see that we use only def and there is no self because it is not in the class. But if you are using a class like this one, this function is inside the class. Then we need to define self in order to call the data members. So the instance methods takes advantage of the object states, and some methods allow clients to access or modify its states. We call it accessor and mutator. The accessor means it is a method that let clients examine the object state. So I can know what is the current value. I can know what is the current state of the data members. For example, I will make one kind of method or function, distance from origin. So distance from origin means I want to know how far a point is away from 0, 0. And usually when we do this kind of accessor, it has the return value. Mutator, it is a method that modifies the object state. For example, translate. So the translate will shift the position from one point to another point according to the given amount or according to the given value. So let's see, if I want to make a method or I want to make a function set location. So you know that the X is originally 0 and Y is originally 0. So I'm going to set the location. Whenever I have a new object, let's set a new location. So the X and Y will have a new values. So you may want to refactor. Well, refactor means we want to change. We want to rename the point class to use this method. So modify the client code to use this method as appropriate. So I gave you this mutator. Let's look at this code in the pie chart. So I'm adding a mutator. So I will have the def self set location, and when you type the set location, it automatically gives you the self. And then let's say I want to set the new X and the new Y. because I want to change the data member, which is the self.x. Now the self.x will be the new x, and the self.y will be the new y. It means originally we have x and y is 0, but I will not modify the x and y directly. I will use a method to modify the x and y. Okay, so let me use this one first. Okay. So what if I want to use this set location? So I can call, let's say I have P1, which is a point. So what is the original value? X will be 0 and Y will be 0. So if I do not use this one, so I'm going to use the P1 set location. I'm going to set to, for example, 30, 40. So the new X will be 30, the new Y will be 40, and if I run this, then the X and Y for the P1 will be 30, 40, not 0.0. Because I'm using this function, and this function has two parameters, 30 and 40, and it changes the value of X from 0 to 30, and this 40 will change the value of Y from 0 to 40. We have the translate. Okay, so this translate, it means the same with the previous code, what we already have here. We have the dx and dy, and then the dx will be added to x and dy will be added to y. But now I'm giving another alternative solution. So what we can do is we can make another function. This will be another value translate, and I will create the dx and dy. But instead of doing the self x equal to self x plus dx and self y plus equal dy, I am using the set location. What is set location? It is the function name. So I am going to set a new x. Okay. So the new x will be self.x plus the dx, and then self.y will be added by dy. There is one question here. The function cannot be recognized. So Python cannot recognize this function. Why? Because this function is inside a class. And this function is an instance function or an instance method. In order to access this one, you need to call the function with the self. So when you call this function inside a class, you need to use the self, because it is related with the instance. So if you understand the instance, then you will understand why we need to use self. So every instance will have different value. That's why in Python, we need to define the self. So the self set location is self.x plus dx and self.y plus dy. So I'm afraid that it will be conflict with this one. So let me just close this one. Okay, let me close this translate. And then let me check from the test point 2. So in my code, I have P1, which is point, and then I have the P1 dot set location 30, 40. So I print the P1 dot x and P1 dot y, it will be 30, 40. So the P2, it starts with 4 multiplied by 3, and then x will be added by 1. So we have this. Now, I keep using the translate. Let's see what will happen if I use this translate, but the translate here has different statement. So if you run, the result will be the same, 11 and 32. So the same function, you can have different statements. What does it mean? So whenever you create a class, whenever you create this kind of problems, let's say if I give you assignment, of course, every student will not be the same. You can have your own function. You can make your own function. So if I know that your function is the same with your friends, of course, you just copy this. Okay. Now let's have another question. Write a method distance that computes the distance between a point and another point. So I would like to calculate the x2 minus x1. So we already have this problem last week. Okay. But now I'm going to use the function in a class. Okay. x2 minus x1 power of 2, and then y2 minus y1 power of 2, and then we do the square. So let's write the distance with this formula, and then let's write the distance from origin that returns the distance between a point and the origin, which is 0, 0. And then let's modify the client code to use this method, to use the distance and distance from origin. So I give you this. Let's try to write it. So in the point.py, I have another function. So you can see in this PowerPoint, I have the import method. So the import method, you can put in the top of the class, because I'm going to use some function in the math. So usually we can just call the math function, and then some of the functions like the square root or square or sinus, cosinus, we can use automatically. Now I'm going to make the class the instance method, which is distance. So the distance will be an instance method. So we need to have self. And then what we want to do is to check the other point. The other point, let's say I have the variable other. Okay. Now we can define the formula. In my example in the PowerPoint, I have the dx. The dx means the delta x. Delta means the difference between the x. So I would like to know the self x will be subtracted to the other dot x. And then I have the dy. I have the self dot x and other dot y. Sorry. So how can we know about this other? So if other has no self, it means it is another object. If we have self, then it is the current object. After we have this one, let's return math.sqrt. So if you click the math, you can see that there are many functions available in the math. You can use cosinus, you can use exponent, you can use factorial, and so on. Okay. So Python already have this built-in function, but I'm just using the sqrt. It is the square root. So the problem will be the dx multiplied by the dx plus the dy multiplied by dy. Okay, so something like this. So this is the distance between 2 points. So I have the distance of 1 point, and this is another point. What about if I want to calculate the distance from the origin? So I have another function, distance from origin, and then self. I need to get the point from the current object. And then, because we know that the problem here, the distance from origin, it will be the distance from the point itself and the origin, which is 0.0. So if it is 0.0, so it means this problem will be x2 minus 0 power of 2 and y2 minus 0. So everything, if it is minus 0, then it will be the number itself. And we can just directly return math.sqrt self.x power of 2. Okay, so you can have self.x multiply self.x, but if I simplify, I can use this one to mention this is exponent, and then plus the self.y power. So you can have like this one. So after you have this, now let's look at the client. Okay, now I'm going to create the test point 3. Okay, let me create another Python file. Test point 03. So let me try to write one by one about this code. So you know already from point, import point. So from the point.py, I'm going to import the point class. And then I have the main function. The main function here, I will create the p1, which is a point. And then I will create p2, which is another point. So we call this is the instance number 1. This is instance number 2. If you see this one, p1 equals p1.x equals to 2, p1.y equals to 3. So let me just give you some other idea. I can do a p1.set location, and the p1 location based on this formula, it is 2 and 3. So I can just put 2 and 3. And if you print p1.x comma p1.y, you will get, okay, I will run this one, then you will get 2 and 3. So the p1x will be 2 and p1y will be 3. Now I'm going to check the p2. So if this one, you have y, okay. Yeah, you can define the p2 set location. Let's say here, oh, why I use the p2.y. Okay, you can define any values. For example, I define the 4,3. So if I print p2.x, p2.y, then let's say I want to translate. So I'm going to translate the p2. It means I will change 4 will be added with 3, so it becomes 7. And then 3 will be added with 2, it becomes 5. You can print p2.x and p2.y. So using this one, you can see that the p2 originally it is 4,3, and once I translate it, it becomes 7 and 1. Now I want to know the distance. The distance, let's make a variable, and it will be p2 distance p1. So I want to know what is the distance between p2 and p1. Print distance 0, 1. So the distance between p2 and p1 is 5.385 something something something. Okay, this is the distance with the formula. Okay, so I think it's different with this one. Now I want to know the distance from origin. Distance from origin means I want to know the distance from that point to 0, 0. So you can directly print p2 distance from origin. It means I would like to have the value from this function and then just print. Then, okay, the distance of p2 from origin is 8.6 something something. Okay. So here you can see, if you click on the point.py, you can see the structure of the class. So if you have this one, if you still have no information about this one, I think you can go to the view, and then you can go to the tool window, and then check the structure. Check the structure, and then you will see that this point class, it has the data members X and Y. How do we know this is a data member? So the X and Y is the data member because we have no parentheses. We have no parentheses. If there are parentheses like this one, then we call this is the function. So we have 1, 2, 3, 4 functions, and we have 2 data members. Okay. Okay, so we are going to learn about constructor. So I think this is the question from Simdoksu last time. What is constructor? Okay, because it will take more time to explain this one, let's have a break. I will continue after the break.